This presentation is on alternating twin pit latrines, and these are permanent sanitation facilities. That's to say, they don't need to be relocated when they become full. So they're best suited to peri-urban areas if there's enough space for them. This alternating twin pit concept can be applied to pour flush toilets as well as to VIP latrines. This slide shows the basic features of an alternating twin pit VIP latrine. There's one superstructure, two vent pipes and two pits, which we'll call Pit 1 and Pit 2. Pit 1, the one on the left, is used for at least a year, and during this time Pit 2 on the right is not used and the squat hole over it is blocked off. At the end of year 1, or at the end of year 2 if the system's been designed for an alternating cycle of 2 years, Pit 1 is taken out of service and Pit 2 put into service. While Pit 2 is in use, for the next year or 2 years, the excreted pathogens in Pit 1 die. Only a few Ascaris eggs will still be viable. Just before Pit 2 is full, Pit 1 is emptied, and we'll come to pit emptying later in this presentation. This slide shows a demonstration alternating twin pit VIP latrine built at the Building Research Establishment near Stevenage, just north of London. This unit has the pits extending outwards from the sides of the latrine, but they could equally well be located at the rear of the latrine. Here's an alternating twin pit VIP latrine built in rural Tanzania. The pit cover slabs have been removed, so the two pits are clearly visible. This is another example from Tanzania with a squared-off spiral superstructure. Access to the pits is at the back. To the left you can see an open hole over one of the pits. Over the other, bricks have been corbelled upwards to close the pit. This is an alternative to a thin reinforced concrete cover slab. The cover slabs have to be easily removable, as shown here in the demonstration unit at the UK Building Research Establishment. The edge detail is important, as the overlap prevents light entering the pit, and so providing an escape route for any newly emergent adult flies. We often think that VIP latrines are external to the house, but this needn't be the case. The slide shows an in-house alternating twin pit VIP latrine, and this is perfectly satisfactory if 150mm rather than 100mm diameter vent pipe is used. This shows one such in-house latrine in Kumasi in Ghana. It's okay, but really the vent pipe should have been extended above the roof to maximise the wind effect which controls odour. And here is a double unit in a school in Kumasi, one side for girls and the other for boys. And this is a multi-compartment unit used in the prison in Kumasi. Now we come to pit emptying. Obviously the cover slabs have to be removed first, and then, if the pit is a dry pit, that is to say its base is above the groundwater table, it can be emptied manually, and this is perfectly safe, as all the excreted pathogens will have died, with the exception of just a few Ascaris eggs. The material which has to be dug out is inoffensive and odourless, as it will have composted quite well during the period when the pit's not been in use. So it's not a repugnant material at all, and once this is realised by the householders and the emptiers, there's no problem in getting these pits emptied. The material removed can be used on site as a soil conditioner, if there's enough space, or else it can be carted away and used for this purpose elsewhere, or simply landfilled. But if it's a wet pit, and its contents are therefore liquid, it can't be emptied manually, and instead an ordinary vacuum tanker, of the type used to empty septic tanks, has to be used to suck out its contents.